Hi, this is Math 2520, and this video is the second part to section 8.5 with when we're dealing with partial fractions here. We're going to look at some application problems. We're going to do one that's business, one that's engineering based, another one that's business, and then another one that's engineering based. But I think the second engineering is a little bit different than the first. Alright, so a company produces and sells a product with the following revenue function modeled by the equation 100x over x plus 5 times x plus 10, where R of x is your revenue in thousands, x is the number of units sold. Find the integral of the revenue function to determine the total revenue generated from selling 0 to 100 units. And then the second part will be use partial fractions to simplify the integral before solving it. Alright, so we need to do the integral first. And so we'll be using the partial fractions. We'll have 100x over x plus 5, x plus 10. And we're going to let this be a over x plus 5 and b over x plus 10. A lot of the ones before we didn't have an x in the numerator. If you notice, that didn't change anything how we do it. Alright, and you'll see what happens later. Alright, so now we'll find a common denominator and multiply it by the common denominator. So we'll have 100x, because the denominator is always that, equals a times x plus 10 plus b times x plus 5. And then distribute. Oops, I just write that as 10a. And 5b. And then we'll factor x out from the ones we can. So a plus b equals times x plus 10a plus 5b. Okay, so a plus b has to equal 100, and 10a plus 5b have to equal 0. Right, so we have two equations, two unknowns. We can solve it by first having a equal 100 minus b and plugging that in for a. So 10 times 100 minus b plus 5b equals 0. So 1000 minus 10b plus 5b equals 0. Okay, subtract the 1000 over. We'll have a negative 5b equals a negative 1000. Divide by negative 5, you get b equals 200. And then that means a equals 100 minus 200 would be negative 100. Alright, so now we can write out the integral from 0 to 100. We'll have a is negative 100, so we'll have negative 100 over x plus 5 plus 200 over x plus 10 dx. Each of these is going to have the integral be natural log. So we'll have negative 100 natural log of x plus 5 plus 200 natural log of x plus 10. And then we're evaluating this from 0 to 100. So we're not going to we're not going to write plus c, but remember we have limits here. Right. I'll do it this way. See if I can make it work. 0 to 100. Right, so first we plug in 100 to each of these. So negative 100 natural log of 105 plus 200 natural log of 110 minus negative 100 natural log of 5 plus 200 natural log of 10. Alright, so break this up. Negative 100 natural log of 105 plus 200 natural log of 110 plus 100 natural log of 5 minus 200 natural log of 10. And this is something you just have to plug into your calculator. Actually, we can make it a little bit simpler before we do that. Now that I look at it. So, the ones that have 100 with the constant, we can actually put together their natural logs. So, these two, they're subtracting. And so you'll have natural log of 5 minus the natural log of 105, and then the whole thing times 100. And inside that, if they're subtracting, then they're multiplying. Oh, I'm sorry, if they're subtracting, then they're dividing. So we can write this as 100 natural log of 5 over 105. The other one, I'm going to do it in blue, we can write that as 200 natural log of 110 over 10, which is going to be 11. Right. That's going to make this easier to put in your calculator. So natural log of 5 divided by 105 times 100 plus 200 natural log of 11, and I get 175.13. And that's the total amount of revenue generated. Okay, here in a I went too far. In a heat exchanger, the rate of heat transferred is given by the function Q of T equals 15T over T squared plus 4 and T squared plus 1. We'll determine the total heat transferred from 0 to 3 seconds by evaluating the integral. But first we have to use partial fractions for this integral. So 15T over T squared plus 4, T squared plus 1. So we'll have A T plus B over T squared plus 4. And then CT plus D over T squared plus 1. Okay. Multiply by common denominator, we get 15T. AT plus B times T squared plus 1 plus CT plus D times T squared plus 4. And we'll have to FOIL this out. This is where things going to get kind of long. So AT times T squared is AT cubed plus bt squared plus at plus b. And then this one will be ct cubed plus dt squared plus 4ct plus 4d. Alright, so we gotta put this stuff together. Let's look at our t cubes first. We have two of them. So we have a plus c. And we don't have a t cube on the other side, so that equals 0. Then we look at our t squares. We have two of those. So we have b plus d and that equals also 0 since we don't have a t squared. We have two t terms. So we have a plus 4c equals 15. And then we have two constant terms, b plus 4d equals 0. Alright, so we have to find what we can so we can put things together here. So here we have a relationship a equals negative c. So we can say down here negative c plus 4c equals 15. And I'm going to write this farther down here. But the other side we can say b equals a negative d. So here we can say negative d plus 4d equals 0. Okay, so now bringing these two down, the last two down, we can see that 3c equals 15, so c equals 5. So a equals a negative 5. And then 3d equals 0, so d equals 0. So b also equals 0. Alright, so now let's get into the integral. We're going to do integral at plus b in the top. A is negative 5. Negative 5t. B is 0. Over t squared plus 4. Dx plus ct. C is 5. Integral of 5t over t squared plus 1. D is 0. And then dt, not dx, dt. One thing with these is you have the t in the top. These are going to have a natural log of t squared plus 4 or natural log of t squared plus 1. And then if you were to take the derivative, you get a t coming out from inside. So we have to take that into account. So when we do these integrals, we'll get negative 5 natural log t squared plus 4. And then we have to divide this by the 2 because of the 2t. Divided by 2. And then this one, very similar. 5 natural log of t squared plus 1. And then divided by the 2. double checking everything I have written. Okay. And then we'll go integrate this from 0 to 3. I didn't write my limits. Okay, so when we plug in 3, negative 5 halves, natural log would be 9, that'll be 13, plus 5 halves, natural log of 10, minus 5 halves, natural log of 4. Now we're minusing, so minus, and then I put these in parentheses, plus 5 halves, natural log of 1, this one being just 0. Right, so writing this out now, negative 5 halves, natural log of 13, plus 5 halves, natural log of 10, minus a minus, so it would be plus 5 halves, natural log of 4. We can kind of put all these together. So 5 halves, natural log, the ones that are positive multiply, so we have 40 in the top, 40 over 13. It's easier putting a calculator that way. Okay, 2.81. So this is total heat transferred from 0 to 3 seconds with in watts, 2.81 watts. Next one, business one, we're going to a manufacturer has a cost function determined by the equation below. C of x represents cost, x is units. We're going to find the total cost incurred from producing 0 to 10 units. And then we're going to do this by using partial fractions to reduce the interval. So 50x plus 200 over x plus 2 times x plus 5. It's going to equal a over x plus 2 plus b over x plus 5. Multiply by the common denominator, you get 50x plus 200 equals a times x plus 5 plus b times x plus 2. Distribute ax plus 5a plus bx plus 2b, and then we'll set the like stuff together, so a plus b has to equal your 50, and then 5a plus 2b has to equal 200. That's why this one gets a little bit more complicated. We're not dealing with zeros anymore. So we can set this a equals 50 minus b and plug that in. So 5 times 50 minus b plus 2b equals 200. Distribute this, you get 250 minus 5b plus 2b equals 200. Subtract the 250. So our negative 3b equals negative 50. So b equals 50 over 3. I'll make sure I did everything right. Alright, yep, everything's right. And then a equals 50 minus 50 over 3. We'll find a common denominator here. 150 over 3 minus 50 over 3 will give me a equaling 100 over 3. Right, so we have some fractions, but we've seen before these are not that bad. So integral of a is 100 over 3 x plus 2. B is 50 over 3 x plus 5. If you write these backwards, like if you have a over x plus 5 and b over x plus 2, your a's and b's values will switch. Don't let that confuse you. But it really won't matter. You just gotta keep it consistent. So for this one, you get 100 over 3 natural log of x plus 2 plus 50 over 3 natural log of x plus 5. And then we have limits here, since we're evaluating basically the integral from 0 to 10. So we'll plug in 10, plug in 0. So 100 over 3 natural log of 12 plus 50 over 3 natural log of 15 minus 100 over 3 natural log of 2 minus 50 over 3 natural log of 5 okay, we can put these together. 100 over 3 natural log 12 over 2 would be 6, so natural log of 6. And then 50 over 3 natural log, and 15 divided by 5 is 3. Alright, so 100 divided by 3 times natural log of 6 plus 50 divided by 3 times natural log of 3. It's 78.04. And this is the cost in dollars for producing 10 units. Going from 0 to 10 units. Last one, we'll do a fluids dynamics problem. Here we have the velocity of a fluid through a pipe being equal to 2t over t squared plus 1 times t squared plus 4. I'm going to be doing this for 0 to 2 seconds. And we're going to use partial fractions, of course. So let's write this out. 2t over t squared plus 1, t squared plus 4. And this will be at plus b over t squared plus 1 plus ct plus b over t squared plus 4. Multiply by a common denominator. You have 2t equaling at plus b times t squared plus 4 plus ct plus b times t squared plus 1. This is very similar to, I think, the second problem we did. I think it's because the integrals are very, wasn't that one? The integrals are very similar. Same denominator even. Just the 15 is the only difference. So process is all the same here. So 2t, we get a cubed plus bt squared plus 4at plus 4b, and then ct cubed plus bt squared plus ct plus b. Right, so a cubes together, or the t cubes together. I forgot my t, that's why that looks different. T here. So a plus c equals 0. So b plus, oh, that should be a d over here. Let me rewrite this, because I can't use the same letter. They're different values. That should be a d. Okay, so a plus d, and then that also equals 0. Then 4a plus c, that has to equal 2. And then 4b plus d, that also has to equal 0. Alright, so we can solve one of these. So a would be equal to negative c, b would be equal to negative d. So we can plug in a equals negative c, we get 4 negative c plus c equals 2. So that would be a negative 3c equals 2. So c equals negative 2/3. And so a equals 2/3. Right, and then 4 times negative d plus d equals 0. So negative 3d equals 0. Sure, this is b and d are going to be 0. So negative 3d equals 0, so d equals 0 and b equals 0. Okay. So then our integral is now from 0 to 2. And we have a is 2/3, so you have 2 over 3 times t squared plus 1. Uh, 2t over 3 times t squared plus 1 dt plus integral from 0 to 2 of negative 2/3 t squared plus 4. And then that's 2 as well. Negative 2t dt. Right, so here we'll have natural log t squared plus 1 and then 2/3 on front. And then because we are dividing this to have, or taking the integral of natural log, the inside here, because of the chain rule, you have a 2t comes out. We have a 2t there, so we actually won't have a 2 here, we'll have just a 1. It makes it a little easier. Then minus natural log of same thing, 1/3 natural log of t squared plus 4, and then integrate this from 0 to 2. And basically, for both of these, because of the chain rule, we have to divide by 2, and it cancels out that 2. Alright, so with 2, we'll have natural log of 5 minus, that doesn't have to be there, minus 1/3 natural log of 8. Okay, so that's that, and then minus this next one, 1/3 natural log of 1, which is just 0, minus 1/3 natural log of 4. So this becomes 1/3 natural log of 5 minus 1/3 natural log of 8 plus 1/3 natural log of 4. So we can put this all together, 1/3 natural log of 20 over 8 We can do that in the calculator. Point 0.305 would be exact, or not be exact, but be more specific. 0.305. That is the total distance traveled in 2 seconds by this fluid. Alright, so those are applications of partial fractions. In the next video, we'll get into some more internet strategies. I'll see you then.